This video is to explain the first step for our graphing algorithm using calculus. The step that we're going to focus on today is determining the intervals of increase and decrease. And we're going to use this example of y equals x cubed minus 12x. So the first thing we're going to write down are the steps for finding the increasing and decreasing intervals. Hopefully it makes sense that we would get intervals for the places where it is increasing and decreasing rather than points, because increasing simply means the places where the function is rising to the right, and decreasing means the places where the function is falling to the right. So both of these places are going to be a series of points, which we will give as an entire interval. Our first step is going to be find the places where the derivative is equal to 0, which will be the places with a horizontal tangent, so it's neither increasing nor decreasing. Then we will use a sine table to check the sections between the places that had a derivative of 0. So all the spots that it is not a horizontal tangent. If we get that derivative being a negative number or less than 0, it means the original function is decreasing. And if we get places where the derivative is greater than 0, it means that the original function was increasing. So our first step over on the left is to get the derivative of our function. This is an easy one, so we can get the derivative using the derivative of a polynomial. But even if it was a really difficult equation, we are very good now at finding the derivative. So find the derivative, set it to 0, and solve. So after solving, we figure out that horizontal tangents occur when x is equal to positive or negative 2. These are considered critical numbers. We're going to find other critical numbers later on with our full sketching algorithm, but for today we're focusing on increasing and decreasing, and the positive and negative 2 places where it's neither increasing nor decreasing are called critical numbers. You will recall that we know how to do sine tables, so we're going to do a sine table here. We're going to break up the sine table based on those two critical numbers. So less than negative 2, between 2 and negative 2 and 2, and to the right of 2. On the top row here of our sine table, we could put the equation. So we could put 3x squared minus 12, or we could put the factored version. Since it's an easy one, I'm just going to put f prime at x, and then I'm going to sub a number that is in each interval into the equation for f prime at x. So I'll start by subbing in a number that is between negative infinity and negative 2, such as negative 10, and then determining whether or not the answer is positive or negative. And when you do that, you get positive, negative, positive. These values tell us about f at x. So notice that the two columns of the table, one has the title of f prime at x, those are positive and negative numbers, which tell us that the original function f at x is increasing when it's greater than 0 and decreasing when it's less than 0. Now this question didn't ask us to find the maxes and mins, but it turns out we can. The fact that it's increasing and then decreasing means that must be a maximum at an x value of negative 2, and then likewise, if the function goes from decreasing to increasing, you have a minimum at x equals 2. To get those full coordinates, we come back to the original equation and sub negative 2 and positive 2 in, which gives us 16 and negative 16 respectively, so we can fill that information in. It's always useful to have the exact values of the maxes and mins. So finally, we can conclude that our original function is increasing on the intervals from negative infinity to negative 2 and 2 to infinity from our sine table, and decreasing between negative 2 and 2. Since this is our very first example, I'm just going to display the graph of this original function as well, just to show what it would look like. So there it is. And if we label the x values of negative 2 and 2, you can see that we were correct. We have our max and our min there. And I'll highlight in the same colors the increasing intervals, so between negative infinity and negative 2, and from 2 to infinity, and the decreasing interval in the middle. So it all matches up, and you can see how if we're trying to make an algorithm for graphing, that's very key information.